S. Chand presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Everyone is living in a building where there is a lot of rooms, lot of floors and a huge space with internal circuitry of number of electrical elements like tube light bulb, motor, generator, ACs and so on. So there is huge inbuilt circuitry within this walls which you will never be able to see. But if I wish to find out what is the current flowing in the building, what is the load in this building, how I can find out what is the cooling system I require, or what is actually going on each floor, I need to solve the circuits. I need to find out what is the total resistance in circuit, or what is the nodal point where I can see what is the total voltage coming on each floor and so on. So for this I need to analyze the circuit, and for analysis purpose I need mesh analysis and nodal analysis, where there are a lot of loops or meshes which I consider. A room is a mesh, a floor is a mesh, or the points, junctions are the nodes which are there on each floor or each room or each building. So my analysis will help me to find out the total load, total losses in the circuit, what is the temperature rise. If I wish to give a constant voltage, what is the voltage drop, or vice versa. If I need constant output voltage, what will be the input voltage, so that I maintain total output voltage at the end point or the load point. So this analysis is basically circuit analysis, and we use mesh and nodal analysis for this, wherein we use, or we can say that this is the application of Kirchhoff's law, which we studied in my previous video. Hi, I am Professor Anjali Garg and welcome to S. Chand Academy. To know more about this topic, you can refer to this book by S. Chand Publishing, the link to which is given in the description box below. And today this lecture is all about mesh analysis and nodal analysis. So we'll start with mesh analysis. Mesh analysis uses KVL, Kirchhoff voltage law, where we find out voltage in a loop. So this is analogous to using Kirchhoff voltage law. There is a certain difference in using mesh analysis and using Kirchhoff voltage law. In Kirchhoff voltage law, I normally solve the circuit using current division. That means if this is my node, I divide the current into I1, I2 and so on. But in mesh analysis, there is no division of current. There are n number of meshes. Mesh is a closed path where the current flows. So if I consider this as mesh 1, this as mesh 2 and so on. So there will not be any division of current at node. So this is a major difference using mesh analysis and Kirchhoff voltage law. So what is the benefit of mesh analysis compared to Kirchhoff voltage law? Because there is the number of variables or the usage of current division rule will decrease. So I do not need to find out total resistance of circuit, total current, then current division. If there are 100 of branches, so if I want to find out current in 100th branch, then I have to find out total resistance, total current, and then divide further to find out the current. It takes me hours to find out the current in the last branch. But for this, the number of loops will decrease because they are not dependent upon number of branches. So it will take less time. Also, I can design a matrix, and using computer program, I can find out current very easily as compared to Kirchhoff voltage law. Though it is using Kirchhoff voltage law, but the basic difference is I am not dividing current at node or junction. So let me take the same example. So I am removing this so that it do not make any confusion. So now I have input voltage. I'll take this resistance as R1, R2, R3 and R4. And I am taking for simplicity only 2 loops. So I'll apply KVL at loop 1. So let me start with KVL at loop 1. V, this is for loop 1, V minus I1 R1. Now what about this current, this common resistance, this R3 is common to both the loops. So let me show you separately. This is R3. My current I1 is like flowing like this and I2 is flowing like this in this common resistance R3. Now I do not know whether my I1 is greater than I2 or I2 is greater than I1. So I cannot say whether I am moving in the direction of current or opposite the direction of current. So I do not know whether I am writing minus IR or plus IR as discussed in my KVL video, where I explained that when I am moving in the direction of current minus IR and when I am moving opposite plus IR. So I am not aware of whether my I1 is greater than I2 or not. So how I can now write this equation? So I assume let I1 is greater than I2. In that case, I am getting I1 minus I2. Please note that in this case, my I1 and I2 are opposite. So I am taking minus, difference of these two. So I have taken first case, I1 is greater than I2. So that means my I1 is having bigger value as compared to I2. So my final direction will be downward. Now I am moving, my final direction will be downward and I am solving my circuit like this. So I am moving in the direction of current. So I will write minus IR, minus I into R for the case when I1 is greater than I2. Okay. Now I will go back again. Suppose I take I2 greater than I1, second case. So that means my I2 is greater than I1. So I will write difference I2 minus I1 because both the current are opposite. So my final direction will be upward because I2 is greater than I1. Now I am solving my circuit like this. So I am moving in the direction opposite current. So plus IR, so I will write plus I into R. Now you can see that this and this is same. If I take my minus inside, I am getting same value. So it doesn't matter whether I am taking this or this, both are giving me same result. So I can take either I1 greater than I2 or I2 greater than I1, it makes the same, it gives the same value. So just to avoid confusion, I take the current greater than the other one in which I am moving. That means if I am moving in loop 1, I will take I1 greater than I2. If I am moving in loop 2, I take I2 greater than I1. So let me complete this equation again. Negative to positive plus V, direction of current minus IR. Now because I just explained I am moving in loop 1, so I will take I1 greater than I2. So that means my final direction will be like this and I am also solving my circuit like this. So my direction is same, so minus I into R is 0. So I am repeating again, in mesh analysis there is no division of current at node, current remains same in a loop. The loop in which we are solving, we take that loop current greater than another current if both the currents are in opposite direction. So that I do not confuse with minus IR or plus IR concept. Now on similar note, let me explain you second loop equation. I am moving like this, I am moving like this. So I am moving in the direction of current minus I into R. I am moving the direction of current minus I2 into R4. But now for this common resistance, I have said that the current in the loop in which I am solving, I take this current I2 greater than I1. So I2 minus I1, and because I am moving in the direction of current, minus I into R is 0. So now I have both the equations. I solve these two equations and find out current I1, I2 using these two equations. So my only variable is I1, I2. The question is, what is the current in each branch? For this R1, I1, this is I2, this is I2. For R3, it is I1 minus I2 or I2 minus I1, which one is greater than the another one. So this is mesh analysis. Okay, let me take an example. So I have two loops. So I'll take two variables, current I1, current I2. Now I have to find out two equations because there are two variables I1, I2. So let me start with first loop, loop 1. Okay, loop 1. Start from this side and I am solving the circuit like this. So I am solving my circuit like this. So start from this point. This is minus 2 plus 10. I am moving the direction of current minus IR. So minus I into 10 ohms. Then now this common resistance I will explain again. This is 40 ohms. So my I1 is like this, I2 is like this. Why I am drawing this like this? Because I need to check whether my currents are opposite or not. If both the currents are in same direction, I simply have to take I1 plus I2. But for this particular case, because I assumed, so I have taken these as opposite in the common branch. So what will be the current? Because I am solving first loop, so I am taking I1 greater than I2. So I will write minus I1 minus I2 into 10 is 0. Okay, for second loop, start from this point. Again, I will solve like this. So minus 20 into I2 for this case. Now plus to minus, minus 20, common resistance 40. Okay, I guess this is 40. So then this is minus 40 I2 minus I1 is 0, because now for second loop I have taken I2 greater than I1 because the concept remains same as discussed earlier. Now using these two equations I can find out I1 and I2, and for resistance R1 I have current I1, R2, I2, and for 40 ohms I will make the difference of I1 and I2 to get the value of current in 40 ohms. So mesh analysis is I am using Kirchhoff voltage law. Second thing difference is that between Kirchhoff voltage law and mesh analysis, that current do not divide at node. So current will remain in same in each loop. So if there are 10 loops, there will be 10 variable, 10 currents, and current will not divide at node or junction as is done in Kirchhoff voltage law. So now next we will move with nodal analysis. So nodal analysis is basically using KCL. Now there are n number of nodes. There are n nodes for a given circuit. So I will take out of this n node, I will take one node as reference and rest n minus nodes we assume voltage of each node with respect to reference. Now why we have done this? Because voltage cannot be obtained at a single point. We require two terminals between which we measure the voltage. So one is the reference one point, another point is the node. For example, if I have the voltage, if I have the circuit like this, suppose, so this is taken as reference and I assume voltage of this node as V1. So this V1 is between this node and this node. This is not a node. This is not a node, this is not a node, this is not a node, and this is not a node. As per definition, node is a point where at least 3 or more than 3 branches meet. So all these cross are not the nodes. I have taken this as reference. So there are two nodes, node 1, node 2. So I have taken 1 as reference and I assume the voltage of that another node with respect to reference, because voltage is only measured between these 2 points. It cannot be measured at a single point. So there is, if there are n nodes, n minus 1 equations of in terms of voltage will be used in nodal analysis. So there will be n minus 1 equations in nodal analysis because I have taken 1 as reference. And with respect to reference, normally that reference is ground. So with respect to ground, I assume n node voltages and then I have n variables for which I have to solve this any circuit using nodal analysis. Now there are 1, 2. Now please note that this and this node is same point because there is no resistance in between. I can also show that this is my single node. So I have only 3 nodes, not 4 nodes. So this is taken as reference. I assume the voltage of first as V1 and second as V2 with respect to reference. So there are 2 variables left with me with respect to reference. So I have 2 equations which I need to solve to find out current or voltage at each node or each branch. Now let me start with equation of KCL at node 1. So I am applying KCL. Now there is no current given. So I assume the current. If current finally comes to positive, assumption is correct. Otherwise, I have to say that the current assumed is opposite to that of actual direction. So I assume, let this is I1, let this is equal to I3 and let this is equal to I2. So applying KCL at node 1, so current I1 is entering, I2 and I3 is leaving. So entering is equal to leaving. So now I have to put the value of I1, I2, I3 using Kirchhoff law. So let me take first I1. For I1, my circuit will be like this. This is the circuit. So I will start with this as E1, then R1. Now in place of R3 and I3, I can use V1 because I assumed V1 is a voltage with respect to reference. So that was my reference and that was a point 1. So now this is V1. Why I cannot take I3 and R3? Because I cannot take 2 variables in single loop, I1 and I3. So that's why I have taken V1 because we have to find out equation in terms of V1. So now the current is I1. So I have to find out current I1. So using this loop equation, E1 minus I1 R1 minus V1 is 0. So that gives me I1 is equal to E1 minus V1 by R1. So now I got the value of I1 as E1. So I get the value as E1 minus V1 by R1 for I1. Similarly for I2, I will redraw for I2. This is the second circuit. So in place of R3, I3, now I will use V1. This is V1. Then R2, I2, where I have to find out current. And this is V2 with respect to reference. In place of using R4, now I will use V2. So what will be I2? Using this loop equation, I will get V1 minus V2 by R2 is current I2. So what is I2? I will replace the value. V1 minus V2 by R2 is I2. Similarly, what is I3? For third case, for I3, so I3 I am getting now, I have a resistance, single resistance R3 and this is I3 and the voltage across this is V1 with respect to reference. This is plus, this is minus. Why? Because this is reference, and reference is always having low potential with respect to the other terminal. So that's why I have written minus and this is plus. So what will be I3? Ohm's law, V1 by R3. So I'll put the value of I3, V1 by R3. So this is my first equation. I can further solve it by taking V1 common. So when I take V1 common, the rest all elements can come like this, 1 by R1 plus 1 by R3. Whatever is left is V2 by R2 minus E1 by R1 is 0. We can directly use this equation in terms the voltage across which we are finding out KCL is taken outside. Within the bracket all resistance directly connected, so the reciprocal are added, minus voltage directly connected divided by resistance through which it is connected, then minus E1 by R1 voltage directly connected divided by resistance through which connected. Now why this minus? If this battery positive is connected to the terminal, I will take minus, and if battery is like this, I would have taken plus of E1 by R1 is equal to 0, because voltage by current, there should be some current source. Because there is no current source, I have taken this as 0. This is KCL at node 1. On the similar note, I can find out KCL at node 2 for the same circuit. So KCL at node 2, current I2 is entering, I5 is leaving, I4 is entering. So I will write entering as plus. So I2 is entering, then I4 is entering, and I5 is leaving. So again I will derive the equation as done for the node 1 KCL equations. So what is I2? I2 will remain same. So this is my I2 will remain same. So I will write V1 minus V2 by R2. For I4, this is I4. For I4, I will write the circuit similar form. This is my V2, then R5, this is I4, and this is E2. So apply KVL like this, V2 minus I4, not minus, I am moving opposite. So plus of I4 R5 minus E2 is 0. So that gives me value I4 as V2 minus E2 by R5 with a negative sign. So what is I4 now? This is plus of E2 minus V2 by R5. I have taken negative inside this bracket is equal to, what is I5? This is I5. For I5, resistance R4, current is I5, and the voltage across this terminal is V2 with this plus, this minus, because this is reference. So what is I5? I5 is V2 by R4. So I will write what is I5? V2 by R4. So directly or indirectly, this is my equation, but I can further solve it. I will take V2 as common voltage which is there as variable at node 2, then within the bracket 1 by R4 plus 1 by R5 plus 1 by R2 minus E2 by R5 minus V1 by R2 is 0. That is voltage at which KCL is applied. Within the bracket all resistance directly connected, that is this one, then this one and this one. So the reciprocal is being added, minus voltage divided by resistance through which it is connected, minus E2 by R5 is 0. So these are the two equations. So equation 1, equation 2, we have to solve these two equations. I am given with all the value of resistances, all the value of voltages. I simply have the variable only V1 and V2. So I have two equations, two variable, I can find out V1 and V2 using these two equations, using mathematics, simple mathematics, and finding out V1 and V2. After finding out V1 and V2, I can find any of the current. I have E1 given, you have obtained V1, R1 is given, I can find out I1. Similarly, I can find out I2, I can find out I4, I5, every variable I can find out using these two missing terms which I assumed at two nodes V1 and 2, that is V1 and V2 with respect to reference. So this is nodal analysis where if n nodes are given, we assume one node as reference node and we assume voltage of rest of the node with respect to that reference node. And then we apply KCL at all the nodes and we find out equations at n minus 1 nodes. So if there are n nodes, we have taken one node as reference and we obtain n minus 1 nodal equations using nodal analysis. So I have n minus 1 variables. So n minus variables, n minus 1 nodal equations to solve any of the network. So using nodal analysis, we solve very complicated circuits with n number of branches, n number of nodes, and we can find out easily the current in each branch using nodal analysis. So now we move to the practice question. This is example. Now you can see that this is already given as a reference. So this is my reference node. Now assume voltage V1, V2 of these two nodes. Again I inform you that these are not nodes. These are not nodes, and this point both are same, which is third. So I am assuming V1 and V2 with respect to reference. Now my only variable left is V1, V2, which I need to find out using nodal analysis. So I can directly use the equation. I can assume the current, and again if the current comes out to be negative, my assumption is opposite. So let me assume some current. Let this is equal to I1, then this is I2, then this is I3, and now this is I4. So this is I4. Now apply KCL. So at node 1 KCL. So I1 is entering, then I2 and I3 is leaving. So what is the value of I1? I1 is 20 minus V1 by 5 is equal to what is I2? I2 is this. So this is V1 by 10. What is I3? Plus V1 minus V2 by 10. As discussed in theory part. So my only variable left is V1 and V2 in this equation. Similarly at node 2 KCL. So this is node 2, I3 is entering, I4 is leaving, and 4 ampere is also entering. So I3 is entering, I4 is leaving, 4 is entering. So 4 is entering is equal to I4. So this 4 do not have any equation because this is a fixed value, constant value. So what is I3? I3 is this. So I3 will remain same, V1 minus V2 by 10 plus 4 is equal to what is I4? V2 by 20. So V2 by 20. So now again second equation, this is first equation, this is second equation. You can see that both the equation have variable V1 and V2, rest all is given to you. So using these two equations I can find out V1 and V2. Now question is what is I1? Suppose V1 I got 2 volt. Let V2 I got this is not the exact answer. Let V2 is, suppose I am getting 5 volt. Now question is what is I1? So I can directly put what is I1? What is I1? So I1 is 20 minus V1 by 5. So I have the value of V1. So I can write 20 minus 2 by 5, that is 18 by 5 is my answer. This is only let. I have not find out the value of V1, V2, that is you can find out V1, V2 using these two equations, but I am just telling you how to find out I1, I2, I3 and I4 all variables, because I have obtained V1, V2, I am assuming V1, V2 is 2 volt and 5 volt. So using this V1, I can find out I1. Similarly, I can find out I2, that is 2 by 10. Similarly, V1 minus V2 divided by 10, I am getting I3 and so on. So, this is how we are using nodal analysis. These are some practice questions. Any of the question can be used with mesh analysis or nodal analysis. For mesh analysis, suppose this is to be solved by mesh analysis. So, there are two meshes. You can find out, like this is I1, this is I2. So, using loops, you can find out two equations and find out current. Or suppose there is nodal analysis to be used, I take this as reference, I assume V1 and then I find out equation of V1 and then solve this network. Similarly, I can use this as nodal or mesh analysis and so on. So, there are a lot of examples where there is current source or voltage source for practice using both the analysis. So, in this video we have discussed about mesh analysis, then nodal analysis, using Kirchhoff's law in mesh analysis and nodal analysis, and finding out or you can say the circuit analysis using both the techniques mesh and nodal analysis. And why we use mesh and nodal analysis? Because for complicated circuit it is very difficult to find out total resistance, total current, then current division rule. If there are n number of branches, it can be 100 or 200 branches. So, using mesh or nodal analysis, the circuit analysis becomes slightly easy because number of equations reduces in that case. To know more about this topic, you can refer to this book by S. Chand Publishing, the link to which is given in the description box below. If you found this video interesting, then like, share and subscribe this channel and press the bell button for updates.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.